Hello, everyone, and welcome back to a new episode of Advent of Code 2016. We missed day. In the last episode, we did day 7, of course. Day 7 part 2. It's actually 2 episodes that we took to do day 7. And we didn't actually miss day 8 by that much. But I still couldn't have streamed it. I'm going to try to get that done tonight so that maybe tomorrow I can stream 9. I mean, I don't have to do them in order, but it would be nice. So that's what I'm going to try to do. Well, let's see what Part 8 is all about. Two-factor authentication. You come across a door implementing what you can only assume is an implementation of two-factor authentication after a long game of requirements telephone. Okay. The joke here being that, I'm sure it'll link me to a wiki page explaining requirements and telephone, but telephone is the game of like where you say something as like a kid, you would whisper something to someone and they whisper it to someone else, and like it goes around in a long circle, and eventually it's like all of the collective misunderstandings have added up to a word that is really nothing at all like what you said the first time. And you can imagine, I hadn't heard requirements telephone before, but I know exactly what it is. It's when this happens, you're trying to write a program, and there's 50 different people all in a row telling each other this is what the program needs to do, and they pass it on to the next guy. And by the time it gets to the end developer, it makes no sense at all. And so that an implementation of two-factor authentication after a game of requirements telephone is a very poor implementation of two-factor authentication that doesn't really make any sense and checks the wrong kinds of things, but probably has some of the same words as a correct two-factor authentication. At any rate, to get past the door, you first swipe a key card. No problem. Then it displays a code, and you type the code in. And then the door is supposed to unlock, but the screen is broken. Okay. After a few minutes, you've taken everything apart and figured out how it works. Now you just have to work out what the screen would have displayed. Fascinating. Okay. The magnetic strip on the card you swiped encodes a series of instructions for the screen. These instructions are your puzzle input. Okay. The screen is 50 pixels wide and 6 pixels tall, all of which start off. And it has 3 operations. Okay. Rectangle AXB. Okay. So this reminds me a lot of one of the puzzles, actually 2 of the puzzles from last year, where we had a grid of like lights and instructions for manipulating the lights in a square pattern and so on. Rotate a rectangle at the top left, which is A wide and B tall. Fine. Rotate row Y equals A. So, by B. Shifts all of the pixels in row A. To the right by B. Row Y. Where is Y actually being used? Is it not? It's not. So the string Y equals and X equals are just not an interesting part of the instruction. They're just like, it's basically row Y and column X. You can pretend as like an actual word. Okay. Pixels that would fall off instead wrap around. Okay, so here's an example, and we have the same thing where you can shift pixels in a column down. So here's a simple sequence. Rect 3x2 turns those on. Rotate column X 1 by 1. Oh, I see. Yeah, okay. I guess the way the instructions are written sort of makes sense when you read them. Fine. The column where X is equal to 1 shall be rotated by 1. Okay, fine. Rotate row Y equals 0 by 4, shoves all those things to the right. Column x equals 1 by 1, yeah, pushes these two, I don't think you guys can see my mouse cursor, but these two here, and here, go down by 1, and the bottommost one wraps around and comes back on the top. At the end, how many pixels should be lit? Is there some clever way to do this without like just modeling the whole thing? I don't think there is. Because like all of these rotates don't actually turn on any pixels, right? The only thing that can turn on pixels is a rotate. Is a what was it called? Turn on? Rect. Only rect can turn on pixels. But the number of pixels that it actually turns on depends on how many of them were on already, and in order to figure that out, you have to do your rotates. Okay. Well, we're going to learn how to do a little bit of parsing in Python. I bet we're not. I bet we're just going to use regular expressions, as always. So let's just grab this. Oops. And paste it into our input file. Fine. So we have how many lines? Yeah, 171. Interestingly, all these rotates at the end just don't do anything as far as our answer for part 1 anyway, because they don't change at all how many lights are on. So we need to do a few things here. We need to write a parser for the command language. We need to write some sort of internal model for representing the state of things. And we need to write functions for manipulating that model according to things in the command language. Now, the obvious data structure here is a two-dimensional array of Booleans. Maybe we could have a map, or I should say a dict, from tuples, pairs really, to Booleans, or indeed even a set of tuples. A set of tuples does not seem like a good way to do this. It's going to be much harder to manipulate. So it seems fairly simple to implement a function that rotates a row in the two-dimensional list thing. If you assume that it's row major, so we have like a list of rows, and each row is a list of characters. It seems quite simple to implement a rotation function there. What exactly do we do to rotate a column, though, is not so clear. We could do like we could transpose the entire thing and then rotate the row and then transpose back. But that does not seem like the right approach. I guess we can probably slightly adjust the way I was thinking of doing it for rows and make that work for columns as well. Yeah. That sounds good. Okay, I think that much is all doable. And now that we've thought about it for a while, it's time to write a bit of actual code. So the first thing to do is class well, I want to define some functions or classes or something that allow me to represent the instructions. The instruction language of rotates and rects. In Haskell, I would do this by defining an algebraic data type with probably 3 constructors, right? I would have a rect constructor with 2 ints. I would have a row constructor with 2 ints, and I would have a column constructor with 2 ints, and then pattern match. That doesn't seem like the Python way to do things. And indeed, I'm not sure how you would translate such an approach to Python anyway. In Clojure, I would probably do it as a tuple, where the first element is either rect, row, or column. And I suppose I would just have elements 2 and 3 be ints, because as it happens, each of the instructions has exactly 2 int arguments, which is rather convenient, but ultimately not that important. I guess it is a little important. It would be a little bit more flexible to have everything be a 2-element tuple, where the first element is the instruction type, and the second element is a tuple containing all the arguments needed for that instruction. That way, we could adapt to instructions with a different number than exactly 2 arguments. And this is actually basically just re-implementing algebraic data types. It's like a tagged union, right? It's a tuple where the first part is the tag and the second part is the arguments. So I guess that is, now that I've said it all aloud, how you would translate the Haskell approach into Python. And it happens to be what I think is a good Clojure approach. And it seems like a fine Python approach. Alternatively, we could create 3 classes, one for each type of instruction. And the classes could all have a method called like apply that takes a board and returns a new board or modifies the existing board. That seems okay too. And indeed, like, I think Python likes classes in general. You know, as much as a language can be said to like anything, when really it's the culture of people who like it. But you know, the language has tools that are good for dealing with classes as well. So I think that I will try something a little bit. I mean, I have plenty of Java experience. I get classes, but a lot of the stuff that I do, like for fun, is a more functional approach. So this forcing myself to use classes and objects more is a way of getting out of my comfort zone and practicing approaches that seem a little bit foreign to me, which is the whole point of this Advent of Code thing. At least it's the whole reason that I'm doing this Advent of Code thing. You can do it for whatever reason you want. So what I'm going to do is define 3 different classes that are all represent a kind of instruction. So we'll just have one called rect. And I guess we'll give it a constructor as well. Def init self. I remembered the self. I'll forget at least one self sometime this episode. Guarantee it. But for now, we're doing pretty well. Takes a... What argument do the rect constructors come in? Rect. First is the number of columns. Calls rows. Self.calls equals calls. Self.rows equals rows. Fine, and we'll get to the apply later. Class row, I suppose. Def init of self and row and amount. Self dot. So this is like kind of thing that would be really like what we're building here is kind of just a custom tuple. And it would be way, like, in a lot of ways, more convenient to just use a tuple, because then you'd get destructuring, you'd get all kinds of nice stuff just sort of for free. And you wouldn't have to write all this, like, boilerplate nonsense that we're writing now. Like, what advantage, really, are we getting out of these, like, what is going to be 12 plus 2 is 14 lines, right? 12 lines of actual code and 2 lines of white space just to define tuples. Well, the main advantage that we're getting is dynamic dispatch based on type when we call the apply function. Is that really worth it? It's a pretty, like, we're also gaining, like, you might argue, readability, named members. That's nice. For sure. I definitely, there's more to benefit than, like, things you can do, right? Things you can see, making the code more readable. That's a really important benefit. And in some ways, that is what is happening. What we're getting out of this. But, like, we could get, if we were in Haskell, for example, let me just say, I could say data inster equals row int or rect, no, oops, rect would be first, of course, rect int or row int or call int. And, like, that's all it takes to define all 3 of these classes. And then when you want to write a function that operates on one of them, you say, like, you know, foo, and let's say it takes an instruction. Normally we would pattern match here, but let's say I could write case inster of rect xy to, like, now I can use xy. Like, we've checked what type it was and destructured the x and y right at the point of use. Like, it's super convenient. So we get the readability, and we get brevity, and we get dispatch. You know, here we get dispatch and, like, maybe readability, but not brevity. Which is why I'm not so sure that it's really worth using classes instead of tuples. But, you know, here we are. I decided it's probably worth it, but I'm pointing out that it's not as clear a trade-off as it could be in, like, some other languages. Okay, so we defined all those. That was easy. We just typed a bunch of code that really, like, people say that it doesn't matter how concise your language is because you're not gated by, I'm gated by how fast I can think, not how fast I can type. But I just typed, like, 12 lines of stuff that took me about 2 seconds to think. Like, it really does happen that you're gated by typing speed sometimes. And it happens more often in languages that are more verbose. I don't know. I'm complaining a lot about Python today, and so far Python hasn't even done anything really unpleasant to me. So, you know, maybe that's rude of me. Sorry, Python. Sorry, Guido. Okay, so let's write a parse function now, and we'll get around to the apply function inside of these objects later. Def parse of a line to be. Let us say can I wonder how you destructure. Let's try. Whoops. Oh, yeah, it's probably mad about that. Okay. But what I wanted to do was say, let's say that I have x's equals 1, 2, 3. Fine. And I wanted to say x star y equals x's. Is that a thing I can do? No. I was thinking that might give me x to be the first element of x's and y to be the rest. It seems that I cannot. Python what do I want to search for? I kind of want to unsplat destructure. This is not going to be a search that works well. Python assignment destructuring. Okay, well, we got to something sort of reasonable. Okay. Those all get compiled. Yeah, but that's not exactly what I was talking about. Using splats to build up and tear apart arrays in Ruby. I don't need to know about Ruby. Come on, it says Python. This is JavaScript. Boy. All right. Well, whatever I typed was not something that people ask about in Python a lot, I guess. I was just hoping I could get like the head of a list and the tail of a list reasonably easily, and then destructure those separately. But I guess the thing to do is to assign the list to a variable, and then look up the 0th element and a slice of the first to the last, I guess. Okay. So we need to say match equals re.match of line. No, line goes last. Let's put it there. And we have to compose a regular expression that matches it now. Oh. Well, that's not so easy, is it? Is it? It kind of is. Python regex extended mode. How do you turn that on? Extended. Yeah, here's a table of the variable flags. How do you use them? Compilation flags let you... Okay, fine. Yeah, I know what they mean. But how do I use them? Do you compile it and pass it flags? Compile? Yes. re.verbose is the one that I want. Okay. So let's say parse inster regex equals re.compile of r of this string, and Python multi-line strings, you just hit enter in the middle. Actually, let's do this. Python loves this. And we'll assume that it just takes, there's nothing here, and then we say re.verbose. Oh, capital X also works apparently. Verbose. Okay, great. So what we want to match here is I'm going to open a capturing group, not a capturing group. We're going to use question pipe here. Just to say we have 3 different things to match, and we want the groups in each of those things to be given the same numbers. And then we're going to just write use same group numbers in each branch. Let's just leave that on the next line. And what we want to match is either, let's look at the input again, rect some number of digits, x some number of digits, you know what? Let's actually take this and put it here. Oh, I forgot. In extended mode, spaces don't get matched. Is that right? Preceded by an unescaped backslash. Okay. Yeah, so we're going to have to actually put a backslash in there to make the space actually match. Otherwise, rotate row y equals d plus by d plus, oops, we want this in quote, not quotes, parens. Oh, we needed an or here, that was the whole point. Or rotate, is it col or column? Column x equals d plus by d plus all right, so that's the idea, is to match one of these three things and then grab the three capturing groups to decide what to do with it. Yeah, that sounds good to me. What are we going to do? So match equals that. Does Python have like a switch case kind of thing where you can match on a single value and decide what to do? Python switch case or something like it. I mean, it doesn't have switch case exactly, but maybe it has something like it. Dictionaries. Yeah, so some suggestions are to have a dictionary where the key is the case that you want and the value is the thing that you want as the result. Certainly this is a possibility. We could have a dictionary where the key is the first group and the value is a function that takes the second two groups. Possible. And in fact, that should just be fine because we already have such functions in scope, right? Row, call, and rect are two argument functions that want those two things, right? Okay, let's try it. Parse table equals a dict where rect maps to rect, row maps to row, and column maps to call. Return parse table of groups. Parse table. We don't want to call this a match. Yeah, I'll call it a match. It's fine. A match of 0 on int of match. Actually, star of map int over match of 1 plus. Right. So we're going to map int over all of the things in the match except for the first one. And we're going to pass those separately as arguments to the function in the match table under the first value. All right. Well, that's exciting. Certainly a lot has happened in those couple of lines. Invalid expression. That's pretty exciting. Unexpected end of pattern. Why? Hello? What's wrong with that? These balance. These balance. That balances. This balances with that. All right. What are you upset about? This balances. Invalid expression. What is invalid? Unexpected end of pattern. Why? Looks valid to me. Okay, well, first thing to do is, what does this evaluate to? Is this a valid value at all? What the heck is with all these dots? I don't understand. Oh, that was because I pasted a multi-line thing into the REPL. It prints some dots after every line. Fine. It looks good to me. It's got the number of slashes that I want in various places. It has a new line after the comment, so that doesn't count as part of the thing. What are you mad about, bro? Does it want like that for some reason? I wouldn't think that matters. No. Line 23, here. Unexpected end of pattern, but it's on this line. Maybe I need to look up how triple quotes works in Python? Python triple quotes. Like, what is the deal with those? I thought they just closed when you got to a matching triple quote. Triple quotes. End of lines are included in the string, but it's possible to prevent that by adding, yeah, sure, of course. But that's fine. Well, it says unexpected end of pattern. So is that the same problem we would get if we wrote, say, re.compile of this? No, it says unbalanced parenthesis. Why, then, does it write unexpected end of pattern? What if I get rid of that comment? That can't be the problem, right? No, it's not. Okay, well, let's try writing that. That compiles. Okay. So we know it's something in here that it's not happy with. Which branch is it in? That bothers you. How about that? That bothers you too. How about this? This also upsets you. So it's not in any one of the branches. What about this? Does it just not like question pipe? Because that's a thing that really exists. But let's say I threw that out. Oh, Python! Come on, that's in PCRE, right? Isn't it? PCRE question pipe? I don't know. Alternation with the vertical var. Yeah, okay, that's not exactly what I meant. But we'll look at it anyway. Is there like a... What exactly am I looking for? I'm looking for group flags, kind of, right? Branch reset groups. Perl 5.10 introduced it. PCRE 7.2 and later. Okay, Python PCRE version. Python PCRE is 0.7. Support, well, but that's the name of... For comprehensive, yeah, I know, but this is like a different language. Here, let me show you guys, I guess. This is a different module that has alternate PCRE bindings, which is not what I wanted. I wanted to know maybe I should search for Python regex branch reset group. Okay, well here's one it says PyPy 2014. I saw a question pipe in the group numbers will be reused. Okay. Notes on named capture groups. Group numbers will be reused. If they have different group names, then of course those will, yeah, sure. So this is like in PyPy, and I'm not sure if that applies to what I'm doing. Python regex. The only way we would be using the branch in Python's regex module? There's something that's different from the RE module? Alternative regular expression module to replace RE. Okay, do I have that? Import regex. No module named regex. Ugh. Well, that's unpleasant. So I guess Python's PCRE support is not... Man, those have been around for a long time. I'm surprised they're not in Python. Okay. How would I do it otherwise? It's kind of gross, isn't it? Bleh. All right, let's try something crazy. What if I said like from future import regex? Like there's a thing called future. Like, does that exist? No module named future. I thought that was a thing you could do. Am I crazy? I thought that was a way you could get access to like backported features or something. I don't know. Maybe I'm crazy. So what if I wanted to download this? How would I do that? I don't know how to install a module in Python. Like, I see a bunch of like stuff I can download. Python install module? I don't want to figure out how to do it without good regexes. Installing Python modules. Pip, oh my god, pip and py. Do I have pip? Oops, in a shell, please. Pip. Looks like I do. Pip install regex? Oh, hang on. Yeah, I don't remember if you guys are looking at the terminal now. Okay, so I've downloaded a thing called regex. Is that the right thing to have done? Does the web page tell me how to... Like, I see downloads, but that's not the way anyone does it. How do I know that regex is the thing that I'm getting? I think it is. Ugh. Running setup.py install for regex taking a long time. Command. Are you upset about I don't have command failed with error code 1? Why? Permission denied. All right, yeah, sure. Pip install -- user, please. I don't want to install it globally. Like, I could. It's my laptop, but I prefer the Unix way of like only running stuff privileged when you absolutely have to. And preferring instead to put stuff in your user directory. It was designed in an age where like multi-user computers were more of a thing. These days, a lot of computers are single-use user, I should say. Okay, we did it. So if I just run Python, and like, of course, really the right thing to do if I were a good software developer would have been to set up PyEnv for some virtual environment where like I can install it just for a project, but I don't really want to do that. So what if I typed import regex now? That works. Okay, great. So let's kill this buffer. Yes. And let's import regex instead. Regex.compile. Oh, we had this in here. And this. There. Regex. Okay, great. Run Python, please. And if I compile this now, how does it go? Name RE is not defined. Oh, of course. Regex. It compiled! Incredible! Great success. God, this is going to be a long puzzle. It's already about time to cut the episode, but I want to check that we're at least able to parse something first. Let's print parse a line of rstrip. It's not going to print very well because these classes don't print well. That's another thing, is like we put them into classes and now they're like these opaque things that we can't inspect anymore. Whereas tuples you can just look at. Python source.py from input.txt. Nothing. Nothing? What is this? Why you give me nothing? There's a bunch of stuff in the input. Okay, well, let's try one of these by hand. Parse this. Tuple index out of range. Okay, I don't know why that didn't print anything in when we did this, but okay. Print match, please. Match is nothing. Why? Rect space some number of digits and x and some number of digits. That seems right to me. Okay, so let's simplify a bit and do this. Get rid of the group and get rid of all the other cases so that it's just this. Rect space digits x digits. How does that parse? Still doesn't match. Okay, well, at least there wasn't a problem with our grouping operators. All right, let's put those back so I don't forget about them. regex dot. Wait, I'm an idiot. God, when I made this. Come on. Into a top level thing, I forgot to actually use it here. We're using the empty regular expression. Okay, how about now? We get a rect instance 1, 2. Amazing. What if we now run this? No output. I don't understand that. Okay. What if I wrote parse of rotate row x equals 1 by 5? Row rate? Well, that's not going to work. All right, so that didn't work. Print match. Match. Oh, it has no. Yeah, okay. So something is wrong. That's not matching. Rotate row. All right, let's go back and look at the instructions. What are they supposed to look like? Rotate row y equals a by b. Rotate row y equals a space by space b. This looks right. Okay, well, let's try a column one, I guess, just to. Well, actually, let's try one of the ones from the input, huh? Make sure we get. We actually do it with a real thing and not just some made up nonsense. Rotate row y equals 0 by 2. That parses. What did I spell wrong before then? Oh, I did row x, idiot. Okay, great. So, is Python refusing to print them because row and column objects don't have a proper printed representation? Maybe? What happens if I say print of that? That prints. Huh. Weird. Okay, and our columns at x equals, those look good too. I guess let's make sure we can parse one of them. Here's a column. And let's just make sure we can parse it. That worked too. Great. So, dot amount. Yeah, so that's all working fine. All right. So we did a bunch of parsing. We haven't done any actual, applying of those instructions. But there was a lot to learn in, how to parse simple strings in Python. We had to figure out, the right library to get, and, made a bunch of mistakes on the way. And I think we are done with this episode. I'm a bit tired. The episode's gone on for a while. So we're going to call it a break here. And, who knows? These admin of code things may be getting to be long enough that I don't really have the stamina to record it. We always knew this day would come, but we never dreamt it would come so soon. Oh well. I'll at least finish up this this night's exercise, and then we could make a decision about what to do next time. Anyway, thanks for watching, and I will see you next time.